So little did you know that there was actually one more segment left. We already learned about 4 different triangle segments. There's one more segment remaining, and it is called a midsegment. Let's see what a midsegment looks like. So ED, and you're welcome to draw this picture in your notes. ED is an example of a midsegment. If we were going to do what we did in the warm-up and write a job description for a midsegment, what might that be? Bless you. So it's a segment, right? It's a segment that connects to what? Midpoints. Very good. How do you know that E is a midpoint? Well, there is the evidence. How did you know D was a midpoint? There's the evidence. So midsegment is a segment that connects to midpoints of a triangle. You're welcome to write that down, what a midsegment is. Yes, Nathaniel, they will. We'll talk about that after winter break. The segment connecting the midpoints of 2 sides of a triangle. A triangle, of course, will not just have one midsegment. It will have 3 midsegments. So this picture, we didn't want to be too complicated yet, but you could have found the midpoint of the 3rd side, and you can connect 2 more. So it will have 1, 2, 3 midsegments in each triangle. And how many triangles results from that? So there's the original one, and then there's 1, 2, 3, 4 little ones. Alrighty? So, you don't need to write this conjecture down. It's just like one of those is like, oh, that's cool. But since we're trying to make this lesson short, I'll just show you. When you draw all 3 midsegments, the 4 triangles that you create are all perfectly congruent. And you're like, okay, Miss Tan, big deal. Like, that's an equilateral triangle. Of course they're congruent. But what's cooler is when I show you one where it's not an equilateral triangle. So if I drew the correct midpoints of all of these, are these draggable? I can't remember. No, I didn't do that. Okay. I'll just show you. So if I were to trace all of these triangles, then they would also be congruent. So it doesn't just happen.
This is awesome.
Oh, y'all are cute. Good. How fun. Yeah.
Can you go back to the slide and give me a kind of definition?
At the end, yes, I can. It's just a segment that connects 2 midpoints of a triangle. So cool. It happens even when the triangle is weird and scaling and obtuse. Okay, something else cool happens. So not only does it divide it into 4 congruent triangles, but also the midsegment has a relationship with the 3rd side. This doesn't happen just sometimes, it happens all the time. So let's take a look at this demonstration. You see the length of DE? I'm going to drag this right there, and then I'm going to drag it right here. So seeing that, what can you conclude about the length of DE and the length of BC?
Half of BC.
Yeah. DE, very good. DE is 1/2 of BC. How does BC compare to DE?
It's times 2.
There you go. So the 3rd side is double the midsegment. The midsegment is half of the 3rd side. Let's try an example. Solve for UP, AP, and ET. So let's see what's going on. We're going to solve for UP first. So UP is this segment. We know that this segment and the midsegment have a relationship. UP is double NE. So length of UP is 50. All right, AP. AP, which midsegment does AP go with? Which one would
TN.
be? Yes. These are actually parallel to each other, which we didn't really write down yet. They're parallel. The length of AP is?
42.
42. Last one. Find ET. Now I need to find ET, and I can use UA to help me. What is the length of ET? 20. Good job. All right, another example. The problem says DE is a midsegment. So I know DE is connecting a midpoint to a midpoint. So I'm going to label my picture appropriately. BE. Oh, what's up?
Will the midsegment and the bottom one always be parallel?
Yes, I have that in a slide. Let's do this example and then we'll write down the theorem. There's a theorem. They will always be parallel. Yes. Alrighty, and then DE is 1.5x. We're looking for the length of AC. Just like in our other homeworks, we might not use all three of these expressions at first. We're not going to add them all to equal something. We're not going to just throw them into a mashup. We're going to use the markings on our picture, right? What are we going to set equal? What are we going to do? Which ones equal each other? 2x plus 12. Anybody? Equals, I think y'all all started your quiz. Equals 3x plus 4. So if I solve for x, x is 8. Okay. Then we're going to plug it in. We're going to get DE is 12, making AC 24. And here's the last part of this super short lesson. You can write the theorem down. The triangle midsegment theorem. It says the segment joining the midpoints of two sides of a triangle is parallel to the third side. And its length is half the length of the side. So if this is x, then this would be 2x. So these two relationships right here are just really saying what's in gray, but doing it in math language. So we've got it in English and in math language.